Greetings everyone! Today we're going to explore how to write polynomial functions given a graph, x-intercepts, and a random point. Let's think back. We've actually written polynomial functions in the past, but we stuck to quadratic functions. And in that case, we took an x-intercept, an x-intercept, and then also a random point and found our a value and then rewrote our final equation. In this case, we are going to do higher degree polynomials. So now I need to add a third factor. We could even get up to fourth factors if needed. Let's take a look at this example. We want to write a cubic function for the graph that's shown. And in this case, let's leave our answers in factored form. It just makes things a little easier. So as I take a look, I can see I've got an x-intercept, an x-intercept, an x-intercept, and even though it's a y-intercept, this can be my random point. So let's start by setting it up. I would have f of x equals a, and I'm going to have x plus 3, and I'm going to have x minus 1, and I'm going to have x minus 4. Now we need to plug in my random point. So I'm going to plug in -4 for y and 0 for x. So my goal is to find out what that a value is. So I'm going to have 3 times -1, which is -3, -3 times -4, which is 12. Divide both sides by 12. That gets me to an a value of -1/3. So I can now write my final function. F of x is equal to -1/3 x plus 3, x minus 1, into x minus 4. So again, just leave those in factored form. We could multiply it out, but we don't need that unnecessary work. Let's take a look at another example. In this case, we don't have a visual graph, but we have points provided to us. The first thing you need to do is identify what type of point each one is. So in this case, I know that this is an x-intercept because it ends in 0, x-intercept, x-intercept, and 2, 1 is going to be my random point. So to start off, I've got f of x equal to a, x plus 2, x minus 0, or you could just put x, of course, x minus 1. Cubic function because there's 3 x-intercepts. Now I need to find my a value. So I'm going to plug in my random point for my x and y values. Oops, that's a 1 there. All right, so let's see what we have here. I have 4 times 2 times 1. I have an 8a, it looks like, is equal to 1. So if I divide that over, I have an a value of 1/8. So now I can write my final function. F of x is equal to 1/8 x plus 2, x minus 0, x minus 1. Or typically, you wouldn't see the minus 0 if you were looking up resources. You'd probably see that x out front, and it would look more like this. So that's more typical, but I'm okay with either answer in our class. All right, let's take a look at a more complex example. In this particular example, we're looking for a quartic function. We're given the intercepts of 2 plus radical 3, -1, 4. Now, if I take a look, that's only 3 solutions because I have to account for the negative here as well. If it's not given to you, you need to assume you have the positive and negative value. That complicates things a little bit, so let's start off by writing our function that we're going to come back to, which is f of x equals a. I'm going to start off with the -4. I'm going to go backwards, the +1. Now this one would be written as minus y because it's a positive 2. So 2 plus radical 3, and I'm going to have x minus 2 minus radical 3. Okay? Now, to make things easier, you really should deal with this first. We're going to FOIL that out, okay? How to make our lives a little easier by taking care of that. So, first would be x times x squared, okay? Outer would be x times negative 2 minus radical 3. That's going to look like a positive x. I'm going to do parentheses for now, and negative 2 minus radical 3. Then I'm going to have inner x times the same thing, so positive x times negative 2 plus radical 3. And last, a negative times a negative is going to be a positive, but how about we just deal with this? So I'm going to have plus. I'm going to have 2 plus radical 3. I'm doing negative here. And negative 2 minus radical 3. So I'm going to have to FOIL that out as well. All right, let's take care of that side first. First and first would give me to positive 4. Outer would be a negative times a negative positive, so positive 2 radical 3. Inner would be a negative 2 radical 3. Last would be a negative radical 9. Look at how that simplifies out. Boom, boom. This is actually a 3, so 4 minus 3, all of this becomes a 1. Oh my goodness, all of that for a 1. Let's take a look at my orange multiplication. Let's distribute that x in. I've got a negative 2x plus an x radical 3. Take care of the blue values I have here, which would be a negative 2x minus x radical 3. And then I'm going to bring down this x squared. All right, let's see what happens here. Positive x radical 3 and a negative x radical 3 cancels out. Very nice. I've got an x squared minus 2x and minus 2x minus 4x. So when I multiply those out, all of that work gets me to this quadratic. All right, so let me rewrite our function now. F of x is equal to a x minus 4, x plus 1, but now I have the quadratic of x squared minus 4x plus 1. Think of how that makes sense. Two irrational values that look like an answer from the quadratic formula coming from a quadratic. That makes sense. So that means that the zeros for that quadratic were irrational. Now I can actually do my work of plugging in my random point. Okay, so my random point is negative 4 and 3. See what that looks like. Equals a. I've got 3 minus 4, 3 plus 1. 3 squared minus 4 times 3 plus 1. A little bit of more work here than we're used to. Let's see, 3 squared would be 9 minus a 12 plus a 1. What do we got there? 9 minus 12, negative 3 plus 1 is negative 2. Does that look okay? No, that doesn't look okay. Let's see, negative 3 plus 1. Oh, yeah, it does. Okay. Let's simplify that. Negative 1, negative 2 is 2. 2 times 4 is 8. So I've got an 8a. If I divide that over, I end up with a negative 1/2. Alrighty. So I'm ready to finally write my final factored form function. I have an f of x with an a value of negative 1/2, x minus 4, x plus 1, and x squared minus 4x plus 1. Alrighty, how about that for a problem? I know it's messy, but remember we did one like this on the board, and like magic, poof, everything simplifies down. Now that previous example had an irrational zero, but what if I have imaginary solutions? How do I deal with that? So let's approach it the same way to begin with. I'm going to have f of x equals an unknown a value Notice I have the x-intercept of -1 twice, so that means I have +1, +1. Remember that means the graph bounces off that value. Okay, now I have plus or minus 3i. Remember, sometimes it might just be written as plus 3i, but you have to account for that minus. Okay, so in this case, it would be x plus 3i and x minus 3i. So let's deal with those imaginaries first. We're going to have to FOIL that out, kind of similar to the previous one. I'm going to have here, I'm going to do it off to the side, an x squared. Outer would be a negative 3ix. I know that seems weird, just bear with me. Inner is going to be a positive 3ix. See what happens there? And last, a positive times a negative is a negative. And I'm going to have a 3i squared. Or I could write it as 3i times 3i if that's easier for you. So in this case, we're going to keep the x squared. Notice how the outer and inner cancel. Perfect. And then the last here, minus 3 squared is a 9, I squared is a -1. So this is all going to become x squared plus 9. Think about that. If I was to solve that, that would make sense. I'm just do this off to the side. Don't write this down. But if I was to solve this, I would have this, and I would have this, which would be positive minus 3. Okay, that makes sense. I got the right solution. So some of you might be able to start to backtrack, and knowing the patterns, you just know what those factors are. So let's simplify what I have here now. This is going to be an f of x equals a, x plus 1, x plus 1. And now this has become x squared plus 9. Much easier to deal with. Okay, let's deal with our random point. So my y value is going to be 26. My x value is going to be -2. All right, I've got here a -1 and -1. A 4, positive 4 plus 9, be careful there. All of that becomes a 13a. Ooh, look how convenient this worked out. We now have an a value of 2. Let's rewrite our final function. All right, we've got an f of x equals our a value of 2. And you could write x plus 1 as squared. That might make your life a little quicker there to write it down. And the x squared plus 9 would be our final function. Again, I know these last two are messy, but just go with it, take your time, use colors, and know that it should simplify down to something easier to work with. All right, so make sure that you check Google Classroom, see if there's anything else you need to get done right now. Check for assignments. Always check PowerSchool, see where your grades are right now. And as always, make sure you're prepared for the next test. Until next time, have a good one.